Hello, welcome to another video. Today we're going to look at expected values of discrete random variables. Okay, and so what that means is if you have a discrete random variable, what do you expect will happen? And it's just like if you're finding the average of, like, say you're a basketball player and you find what your average, how many points you get on average per game. What that number is, that's the average amount. It's hard to say it without using the word average, but it's the average amount that you get. In other words, that's what you expect to get per game. So if your average is 22 points per game, you expect to get 22. Sometimes it might be more, sometimes it might be less, but you expect to get that much. And it's the same in discrete random variables. We call it expected value, but it essentially is just the mean. It's the average. So what are we expecting to happen? And this is really important in like sort of gaming and gambling and all these sorts of things, to be able to sort of figure out what's happened. So the easiest way to explain it is, let's look at a game. Okay, so I've got this game for you to play. All right. So I've got this spinner. That's what that silly circle is. I'm gonna spin this circle, and you're gonna have to pay $5 to play this game. All right. So you're gonna pay $5, and then we're gonna spin this. And depending on where I better put up like a what do you call it? Like a dig. I don't know what you call it. But it's going to spin, and wherever the green triangle ends up landing on is what happens. If it lands on lose, you're going to lose all of your money. Okay, so you've paid $5 and you've lost all your money. If it lands on 2, you're going to get $2 back. So you still lost most of your money, but you got $2, a little bit left. If it lands on 5, you'll just get your $5 back. But if it lands on 20, then you'll get $20 for your troubles. Okay. And so, is this a game you want to play? Are the odds in your favor? Or are the odds in the, whoever's running it, like the casino's favor, whatever? And so we can actually have a look at what's going on. So what we can do is let's let X be the profit from the player. Okay. And there's 4 different situations that can happen here. And so what we can do is we can set up a table with the different profits for each different situation. So let's go profit X equals X. And I said profit, but I meant probability. I've got sort of my words jumbled up there. So let's have a look at the different situations here. So there's 4 different situations. And in the 4 different situations, we'll look at what the profit will be. Okay. So in the first situation, let's do lose first, okay? So let's do losing first, right? In that losing situation, what's the profit by the player? You've paid $5 and you've lost everything. And so your profit is negative $5, right? You've lost $5. And the probability that that will happen is 1/4. Okay, so there's a 1/4 chance that you'll lose $5 in this game. All right, that's the first situation. Let's have a look at this second situation. In this situation, you pay $5 and you lose $2, okay? And so your overall profit is negative $3, okay? And again, the chances of that happening are 1/4. Third situation, let's do this 5. What happens? You pay $5 and you lose $5, and so your profit will be 0, and the chances of that are 1/4. And that last situation, the one we want to happen if you're the player, that is you've paid $5 and you've gained $20. So in the end, your whole profit overall is 15. So you get $15, you're $15 up. And again, that's 1/4. So now that we'll put it into this table, into this distribution table, you can maybe have a look at it and go, does that help us to get a bit of a better vibe as to whether this game is something we should be playing? And so what the expected value is, and some people can sort of see this, some people can't, that's fine. But what we do to find the expected value of if you're playing this game over and over again, over a long period of time, then what's what dollar amount would you expect to be winning on average? And so what we do is we say, well, 1/4 of the time, you're going to get negative 5. And so what we say is 1/4 of the time, we're going to say 1/4 times by negative 5. Okay, 1/4 of negative 5, 1/4 of the time, we're going to get negative 5, right? And then we're going to say plus 1/4 of the time, we're going to get negative $3. Plus the next 1/4 of the time, we're going to get $0. And then plus another 1/4 of the time, we're going to get, plus 1/4 of the time, we're going to get $15. Okay, and let's sort all this out and let's have a look at what we've got. Okay, if we add all these things up, this will be what we expect to win on average over a long period of time. So that's -5/4, so that's -1.25. Quarter times -3, that's -3/4, so that's -0.75. I hope I don't get any of these wrong. And that's fine. That's just 0, the quarter times 0. And that last one is 15/4. And so that is plus 15/4. 16/4 would be 4, so that's 3.75. Did I get that right? 3.75. 15/4 is 3 3/4. Yep, that's right. Okay, and so I'll just add these things. I'm just doing it in my head. Sorry about that. So -1.25 minus 0.75, that's -2. -2 plus that is 1.75. Okay, so let's just have a think about what this means. We've done all the maths here, and it's saying the expected value of X, and remember X is the profit, is $1.75, right? And so that means on average, if you play this game over and over and over and over and over again, on average, you'll win $1.75, your profit. And so that means this game is a good game for the player to play. Okay, it's really good. So if this was at a casino, everyone would be at this table because the odds are in the favor of the player. If you got like a negative value here, if it was -$2 for the expected value, that means that on average the player will usually lose. And if you go and do this maths with roulette tables or anything at a casino, you'll find that you'll always get a negative expected value because the odds are in favor of the casino, of the house. Hopefully that makes sense. And so expected value is exactly that. And what we do to find the expected value, and the formula is down here at the bottom of the page, what we do, and the formula might look a bit strange, is that we add up, that's what that symbol, that sigma, and we add up all of the x's times by the probabilities. Okay, so that's exactly what we did up here. What we did is we multiplied the x's by the probability, so -5 times a quarter, and then we add it to -3 times a quarter, then we add it to 0 times a quarter, and 15 times a quarter. So we add up all of those pairs inside of our probability distribution table, and that gives us our expected value, and there is the formula for that. Sometimes we can write it as expected value of X, but we can also write it as mu. Okay, so we set at the top, I think I did, no I didn't, but that symbol there, that one there, that mu is a symbol for the mean, the average, and so we can write that in any place. So that's how we find the expected value. A couple of properties. If you've got a linear transformation of a particular, you've got X that's had A and B are just constants, multiply by them, then those constants can come out of the expected value, and so it's just A times by the expected value of X plus B. So it's just like a bit of an expansion within a linear transformation of that. And if you've got two random variables, x and y, then the expected value of x plus y is just equal to the expected value of x plus the expected value of y. A little bit hard to understand that. Let me just show you an example where that makes sense. Okay, so let's say that x is the random variable of the time taken to take a shower in the morning, and y is the random variable of the time taken to eat breakfast. And it says here the expected value of x, in other words, how long we expect to take in the shower, is 7.5 minutes. And the time taken to eat breakfast, we expect it to take 12 minutes. So E of y, expected value of y is 12. So part A there, it wants us to find the expected value of EX plus EY. And so that's just equal to E to the X plus E to the Y. And you'll see why this makes sense now. So it's just 7.5 plus 12. So 19.5 minutes. Okay. I didn't say minutes, but you get the idea. I could say up here, minutes, etc., etc. Okay, and so you can see now why this is true is because, well, it makes sense. If you got the expected value of two things, then of course when you then you say, well, if the expected value to time to take a shower is 7.5 minutes, and the expected time to eat breakfast is 12 minutes, then of course the expected time to do both of those two things will be 19.5. That just makes sense, and I hope that makes sense to you as well. Let's have a look at part B. What's the expected value of 5x? In other words, what's the expected value if you're going to take 5 showers? And I don't know why anyone would take 5 showers, but as, as we've got, let's have a look. And so what it says there is if we've got any constant in front of x, that constant can come out the front. So that's equal to 5 times e to the x, which is 5 times the expected value of x is 7.5. And so what's 5 times 7? That's 37.5. Did I get my maths right? It's a bit late tonight. 5 times 7 is 35. 5 times 0.5. Yeah, that's right. So 37.5 minutes. Okay. And so again, that just makes sense, doesn't it? If it takes you 7.5 minutes to take a shower on average, then 5 showers will be 5 times that long. So it just makes sense. Now that you sort of see an example, hopefully that those properties up here are making more sense. Lastly, nice and simple, what about the expected value to eat 3 breakfasts? It sounds silly. 3 breakfasts plus an additional 5 minutes to do something else. Okay, so what's the expected value of that? Well, again, that 3 can come out the front. Expected value of y plus 5, exactly what you would think. 3 times the expected time to eat breakfast, which was 12 plus 5, 36 plus 5, so it's 41 minutes. Hopefully that makes sense now that you've seen some examples. There's some really handy properties that we can apply to expected values of x. Hope that makes sense. Hope that you're going to head down to the casino and look at all the probability distributions and find out that you'll get ripped off no matter what you do. No worries. See you in the next video.